To the exam walkthrough for exam 1 from spring 2023 for the course MA 16010. Let's begin. The first question is find the limit as x approaches 0 of e to the x minus 1 over x. Given this handy dandy table, we're going to fill this table out to find the limit because, as you can see from the function we were trying to find the limit of, we would be dividing by 0, so that would give us a d and e. So starting from the left, we have x is negative 0.1. If we plug it in, we will get 0.9576. Then for negative 0.01, 0.9950. For negative 0.001, we get 0.9995. And then for negative 0.0001, we get 0.9995. Now from the right side, for 0.1, we get 1.0517. For 0.01, we get 1.005. For 0.001, we get 1.0005. And finally, for 1.0001, we get 1.0. So as we can see, this one on the left side for x equals negative 0.0001 is very close to 1, and on the right of 0.001 positive is essentially 1 with a couple decimal places afterwards but not being 1. So we can see that for f of x, the limit as x approaches 0 of e to the x minus 1 divided by x is 1, or a. Now for question 2. Given the system of equations, find the discontinuities of f of x. So for discontinuities, we are looking for jumps and holes. So to do this, we want to see, this is a piecewise function, so we want to see at x equals 0, x equals 2, to see if those points, if between the two functions, for example, 2 cosine of x, where x is less than 0 and x equals 2, where it starts at 0, we want to make sure that those two values are the same. So for the first one, 2 cosine x, if we plug in 0, we can see 2 cosine of 0 equals 2. Now for the second part, we see x plus 2. If we plug in 0 again, where those 2 points of the piecewise meet, we would get 0 plus 2, or 2. So we can see that between the first two, there is continuity. Now, between the second and third functions, we need to check this too. So, at x equals 2, for this last part, there's no x, so that last part would equal 3. We can obviously see that 3 is not equal to 2, so there is a jump here. So, we can say that the answer is C. Okay, moving on to question 3. Use the graph of f of x shown below and choose the correct statements. So looking at these statements, we can go ahead and check this first one. F of x is discontinuous at x equals minus 3 and x equals 2. So at x equals minus 3, there's a very, very big hole. And at x equals 2, there is also a hole. So this function is discontinuous at both of these points. So this is true. Now, as the limit of x approaches negative 3 from the left, notice this negative sign means from the left, f of x equals 2. So if we go from the left side here, approaching negative 3, so if we go on this side, we can see that the limit does in fact equal 2. Now, for the next one, as the limit of x approaches negative 3 from the right side, see the plus sign? F of x equals 3. So again, if we go from the right side to negative 3, we can see that it does indeed equal positive 3. And finally, the limit of x as x approaches 2 of f of x does not exist. So we can see that if we approach from both sides, because there is no right or left side or a plus or minus power on that 2 in that limit, we need to know that the limit as it approaches from both sides equals essentially a quantity. In this case, both sides go to positive 2, so this limit does exist. So this is not a true statement. Now, if we look at our statements below, we see that 1, 2, and 3 are true. So that would give us D as our answer. Okay. Question 4. Which of the following is the correct limit definition of the derivative f of x equals x or 7x minus 12? So I'm going to zoom out a little bit so we can see the answers. The limit definition of the derivative is f of x plus h minus f of x over h. So we just need to plug in x plus h for x in the function, so let's do that. So f of x plus h equals 7x plus h minus 12, and then f of x is exactly what it is, 7x minus 12. We put it all together, we get 7x plus h minus 12 minus 7x minus 12 over h. Now, this would be E. The biggest thing with these types of limit definition questions is that algebra will be the first thing that will most likely trip you up. Okay, question number 5. This is a derivative question. So, find the derivative of y equals 6 root x minus 7 over x cubed plus 3 over 5 cube root of x squared. Now, to make this a little bit easier to see, where I'm going to write all of the square roots and the x cubed as improper. So we say 6 times x to the 1/2 minus 7x to the negative 3 plus 3/5 x to the 2/3. Now we're going to do this one term at a time. So the first term, the derivative is we want to multiply 6 times 1/2 x to the 1/2 minus 1. This equals 3x to the negative 1/2. Now for the next term, negative 7x to the negative 3. Now, negative 7 times negative 3, x to the negative 4, because negative 3 minus 1, that equals 21x to the negative 4. This last term, 3/5 x to the 2/3, if we multiply, so 3/5 times 2/3 x to the 2/3 minus 1 equals, we can cancel out these 3's, we would get 2/5 x to the negative 1/3. Now we're going to put all of these 3 terms together. We would get y prime equals 3x to the negative 1/2 plus 21x to the negative 4 plus 2/5 x to the negative 1/3. Now we want to write it like in the form of the question, so remove all these negatives and put them in the denominator. We would be left with y prime equals 3 over the square root of x, because x to the negative 1/2 is 1 over square root of x, plus 21x to the 4th, plus 2/5 the cube root of x. Or that gives us D. Okay, question 6. I'm going to go ahead and move this out of the way a little bit. Give a little bit more space. Find the limit as x approaches 3 of x minus 3 over x squared minus 5x plus 6. So, with these questions, if we were to plug in 3 at the bottom, we would see that 9 minus 15 plus 6 equals 0. So that's a D and E. We can't find the limit of a 0 over 0. So, instead, we can try to find ways to reduce the limit. So in this case, if I rewrite it, we say limit as x approaches 3 of x minus 3 over x squared minus 5x plus 6. Now we can see that the bottom is factorable. We can see that it can be factored into x minus 3 and x minus 2. And let me rewrite this to make this more clear. X minus 3 over x minus 3 times x minus 2. We can see that the numerator and denominator cancel. So we are left with the limit as x approaches 3 of 1 over x minus 2. Now, we can see that if we were to plug in 3 for this x, we wouldn't have 0, which is good. We don't want to be finding the limit of something that has that doesn't exist. So now that we plug in 3, it would be 1 over 3 minus 2, or 1, which is F. Number 7. The position of a particle moving in a straight line is given by S of t equals negative 18t squared plus 72t plus 180. What is the particle's position when its velocity is 0? So we need to find the velocity. As you may know, S of t, or S prime of t equals the velocity. So let's find the velocity by taking the derivative of S of t, which is negative 18t squared plus 72t plus 180. So we would find that the derivative, or the velocity, would be negative 36t plus 72. Now we're trying to find it when the velocity is 0, so we just set this equation equal to 0. Now if we solve, we have negative 72 equals 36t, t equals 2. Now to find the particle's position, we would plug this time value back into the original position equation. So S of 2 equals negative 18, 2 squared plus 72 times 2 plus 180. When we plug that into our calculators, we get 252 as our answer, or A. Question number 8. Find the equation of the tangent line to the graph of g of x equals x to the fourth minus 2x cubed at x equals negative 1. So for tangents, tangent line is the slope would be of that line would be the instantaneous rate of change, or the derivative. So g prime of x equals our slope. So let's go ahead and find g prime of x. G prime of x equals x to the fourth, so that we 4x cubed minus 2 times 3 is 6x squared. Now to find the slope at a particular point, we would plug this point in at negative 1. So g prime of negative 1 equals 4 times negative 1 cubed minus 6 times negative 1. So that would give us negative 4 minus 6, or 10. I'm going to move this to the side so I have a little bit more space. Now we just need to write the form of a tangent line. So we know that the equation of a tangent line is y equals mx plus b. Plug in the slope, we get y equals negative 10x plus b. Now, what do we plug in for y? Well, we need to find y for this original equation. So g of negative 1 equals negative 1 to the fourth minus 2, negative 1 cubed, which equals 1 plus 2, or 3. So let's plug this back into the equation. We'll get 3 equals negative 10 times negative 1 plus b. So that's 10, 3 plus b. B equals 7. Put it all together and we would get y equals negative 10x, minus 7. Or A. Forgot the negative there. Question number 9. Given f of x equals x squared minus 2x times e to the x plus 1, find f prime of 0. So when we have two things multiplied with each other, we have two choices. We can either multiply out and distribute, or we can use something called a product rule. product rule is, let's label this G and this one H. Product rule is G prime times H plus G times H prime. So let's go ahead and find our G prime. G prime of X equals X squared, so that's 2 times X minus 2. H prime of X equals e to the derivative of e to the X is e to the X. Derivative 1 is 0. So then we plug it all in. So 2x minus 2 times h, so that's e to the x plus 1, plus g, x squared minus 2x, times e to the x, h prime. So we're trying to find f prime of 0. So let's go ahead and plug 0 in here. So that would be 2 times 0 minus 2 times e to the 0 plus 1 plus 0 minus 2 times 0 e to the 0. So we can see on this right side that this part right here is going to be 0, which automatically knocks out this entire term. And this is going to be 0 too. So let's go ahead and rewrite this. Negative 2 times e to the 0 plus 1. We know that e to the 0 is 1, so negative 2, 1 plus 1 equals negative 2 times 2, or negative 4. That is answer choice D. Question 10. Let y equal 1 plus x squared over 1 minus x squared. Find y prime. So when we're dividing, we can use something called quotient rule. If we label the top again as G and the bottom as H, we can say that H times G prime minus G times H prime over H squared equals y prime. Now, let's go down a little bit. Let's go ahead and find G prime. So G prime equals d dx of 1 plus x squared. So the derivative of 1 is 0, and the derivative of x squared is 2x. Now let's find h prime. H prime equals d dx of 1 minus x squared. We can say the derivative of 1 is 0, and the derivative of negative 2 x squared is negative 2x. And we're going to plug it all in. So h is 1 minus x squared times negative 2x minus g, which is 1 plus x squared, times h prime, which is negative 2x. Actually, that first term I messed it up a little bit. It was h times g prime. G prime is 2 of x, not negative 2x. I'm going to move some stuff around so we have a little bit more space. Now, and then finally, put that entire thing over h squared, which is 1 minus x squared, the whole thing squared. Now we're going to simplify this numerator. So we're going to distribute, so this first term, so 2x minus 2x cubed minus negative 2x plus, minus 2x cubed, all over 1 minus x squared squared. Now we're going to simplify again, which would give us 2x minus 2x cubed plus 2x plus 2x cubed. Now we can see that, over 1 minus x squared squared. So we can see that the 2 times x cubed cancel out, and we are left with 4x over 1 minus x squared squared, or B. Okay, moving on to question 11. Given that f of x equals 5 cosecant x times cotangent x, find f prime of x. So this is another product rule. We have two things that are multiplied with each other. So let's rewrite this. Let's label cosecant as f and cotangent as g. So again, reminder, product rule is f prime of x, g of x, plus f of x times g prime of x. Keep in mind that when we have constants like this 5 in the front, we can just throw it on the outside of this. So let's go ahead and find f prime of x. F prime of x equals dx of cosecant x, which equals negative cosecant x cotangent x. G prime of x equals dx of cotangent x, which equals negative cosecant squared x. Now we can plug everything back into this original equation, and we have 5 times negative cosecant x cotangent x times g, which is cotangent, times cotangent x, plus f of x, which is cosecant, so cosecant x times g prime, which is negative cosecant squared x. Now, to simplify, we have negative cosecant, forgot the 5 in the front, negative cosecant x cotangent squared x minus cosecant x cubed. Lastly, distribute the 5, so negative 5 cosecant x cotangent squared x minus 5 cosecant cubed x. Now that looks like answer choice A. And finally, last but not least, on to the last question. This uses a couple of different things. So first we see some division. So this will be quotient rule. And also we see that is inside something cubed. So this will also have chain rule. So we'll need chain rule and quotient rule. Now let's start as a reminder, chain rule is, let's say that this inner part is u. So it would be, and this 3 is n. Reminder, the chain rule would be n times u to the n minus 1 times u prime. So essentially, we have to take the derivative of the inside and multiply it against the original quantity. So, and again, quotient rule is g of x, f prime of x, minus f of x, g prime of x, over g of x squared. Now let's go ahead and start with the inside with chain rule. So, or not the inside with chain rule, the inside with quotient rule. So let's label the top as f and the bottom as g. So we can say f of x equals x, g of x equals x plus 2, f prime of x equals 1, is the derivative of x equals 1, and g prime of x also equals 1 because the constant has a derivative of 0. Now if we plug it into our quotient rule, we would find that g of x, so that's x plus 2, times f prime of x, which is 1, minus f of x, which is x, times g of x, which is x plus, g prime of x, which is 1, all over g of x, so x plus 2 squared. Now, if we simplify by distributing the top, we can find that this is x plus 2 minus x over x plus 2 squared. Now again, in the numerator, we can cancel out the x's, and we are left with 2x plus 2 squared. Now, this is just the inside of this thing, is just the inside of this thing. So we need to do the whole thing now, right? So for the minute, let's replace what this is inside with u. So we can say 27 u to the third. Okay, moved over here. It's a little messy, I'm sorry. So to find the derivative of this, we would say 27 times 3 is 81. So 27 times 3 u. So we do 3 minus 1, because when we take the derivative, we take 1 away from the power, 2 times u prime. So 27 times 3 again is 81. U squared we can replace with the original u, which is that x over x plus 2. Square it, and then we can replace this. This is our u prime over here, and we can say, so 2 times x plus 2 squared. Now, the question asks for h prime at 1. So all we need to do is plug in 1 into this equation. So 81 times 1 over 1 plus 2 squared, 2 over 1 plus 2 squared. So this would be 81 times 1/3 squared times 2 over 9. Let me simplify again. 81 times 1/9 times 2 over 9. If we can see that if we multiply, we get 81 times 2 over 81. The 81s cancel, and we are left with h prime of 1 equals 2, or F.